Am I audible? And is my screen visible? Can anyone please let me know? Hello? Okay, thank you. So good evening everyone. Welcome to this NPTEL live session. Good evening everyone. Welcome to this NPTEL live session for the course Introduction to Machine Learning. My name is Awan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this is an extra session. All 12-week sessions have been done. So this is an extra session. In this session I will discuss some practice problems on all the topics covered in this course so far, not any specific week's content. And if you have any questions or queries regarding any of the topics, you can ask me. Okay, we can start solving some problems, and if you have any other questions or queries, you can ask me after this practice session. So this is the first question. Suppose we want to add a regularizer to the linear regression loss function to control the magnitudes of the weights beta. So beta is the weight of the beta represents the weights of the linear regression, and we have two choices, this sigma b and sigma 1 beta and sigma 2 beta. So sigma 1 beta is simply the absolute values of beta, summation over I equals 1 to p, and in sigma 2 beta we are squaring all the beta values and summing it up for I equals 1 to p. P is the number of weight values in the linear regression. Which one is more likely to result in sparse distributions? So these are the two regularizers, sigma 1 beta, this one, and sigma 2 beta, and the definitions of these two are given here, sigma 1 for sigma 1 beta and sigma 2 beta. Which of these will produce sparse weights for the linear regression? And the options are, first option is sigma 1, second option is sigma 2, and in C both the regularizers result in sparse weights, and in D neither of them produce sparse weights. Oh, sorry, these are not sigmas, these are omega 1 and omega 2, sorry. So omega 1 and omega 2, these are the two regularizers. So which of these two will produce sparse weights? You can write your answer in the chat. I have not received any answer in the chat yet. So the answer here is the first one, omega 1, the first regularizer, this one will produce sparse weights. So if you recall what has been taught in the class regarding the regularizers, this is called lasso regularizer, and this one is called ridge regularizer. So this lasso regularizer, which is also known as L1 regularizer, because it just takes the modulus of the beta values and sum it up for I equals 1 to p, all the parameters. So it produces sparse weights, whereas this beta square, this also reduces the weight values near to 0. This is why we use regularizer to decrease the values and make it as close as possible to 0. So this ridge regularizer, this is also known as L2 regularizer, this also reduces the values, but this cannot drive the values to 0, but this lasso regularizer is able to do that. It drives most of the weight values to 0, which we want in case of linear regression, to reduce the number of parameters and to reduce the complexity of the model so that it doesn't become overfit. So that's why option A, omega 1, this is the correct answer. This produces sparse weights, so it makes most of the weight values to 0, and it reduces the complexity of the model. Now question 2, let A m cross n be a matrix of real numbers. The matrix A transpose has an eigenvector x with eigenvalue b. Then the eigenvector y of A transpose A, which has eigenvalue b, is equal to what? So what is the eigenvector of A transpose A with the same eigenvalue b as A transpose? Mishti Pandey says B, which is A transpose X. Okay. Has anyone else found out the answer for this question? So the correct answer is option B. uh, so the eigenvalue and the eigenvector for this matrix is given A transpose, and you have to find out the eigenvector for this matrix A transpose A with the same eigenvalue as A transpose. So the information for this matrix is given, so we can write the eigen value equation for this. A transpose X equals Bx. So this information is already given in the question. Now you have to find out the eigenvector for A transpose A. So for this you can multiply A transpose to both the sides. So this becomes this. Now you can separate out this part and this part. So we have to find out the eigenvector for this matrix. For this matrix A transpose A. So this equation is again of the form of a eigenvector equation. So this is the eigenvector and this is the eigenvalue for this matrix A transpose A. So this is the eigenvector A transpose X with the eigenvalue B. That is what was asked in this question, that the eigenvector y of A transpose A which has the same eigenvalue as B. So eigenvalue is B and the eigenvector is A transpose. So you just have to multiply this A transpose to both the sides and then you get this matrix for which you want to find out the eigenvector, and the eigenvector becomes A transpose X. So option B is the correct answer. Now this is the third question. Which of the following statements are true? There are three options. The chances of overfitting decreases with increasing the number of hidden nodes and increasing the number of hidden layers in a neural network. So this is talking about neural network, obviously, for neural networks. And option B is a neural network with one hidden layer can represent any Boolean function with sufficient number of hidden units and appropriate activation functions. Third option is two hidden layer neural networks can represent any continuous functions with a tolerance value as long as the number of hidden units is sufficient and appropriate activation functions are used. So multiple options may be correct here. I have not received any answer in the chat yet. So there are two correct answers here, B and C. So the first option is the chances of overfitting decreases with increasing the number of hidden nodes and increasing the number of hidden layers in a neural network. So this is certainly not correct. If we increase the number of hidden nodes and increase the number of hidden layers in a neural network, obviously the complexity increases for the neural network model, and if the complexity increases, the model becomes much more prone to overfitting. So that's why we want to make the model simpler so that it does not overfit on the data. So by increasing the number of nodes and hidden layers, the overfitting will not decrease. So that's why the first option is not correct. Second option is a neural network with one hidden layer can represent any Boolean function given sufficient number of hidden units and appropriate activation functions. So this is correct because neural networks are known as universal function approximators. Even with one hidden layer, if you can add sufficient number of hidden nodes in that one hidden layer, you can approximate any kind of function that you want to model using the neural network. For complex models, obviously you would need many more hidden units. For simpler models, you can have lesser number of hidden nodes in one hidden layer, and you would still be able to approximate the function. So that's why option B is correct. And option C says two hidden layer neural networks can represent any continuous functions as long as the number of hidden units is sufficient and appropriate activation functions used. So this is again true for the same reason that I just told for the option B, that neural networks even with one hidden layer and with sufficient number of hidden nodes in that one hidden layer will be able to approximate any function, whether it's discrete or continuous, that doesn't matter. So in this case it asks about continuous functions, but it can do for any functions. So any functions can be approximated even with one hidden layer or two hidden layer, that doesn't matter. Even with two hidden layers it can do that. So B and C are the two correct answers here. Now question 4, this confusion matrix is given, a confusion matrix is given, and you have to compute the recall using this confusion matrix. This true positive is also known as actual positive, and this true negative is also known as actual negative. So actual negative, that means those are already given in the dataset, that those are positives and those are negatives. So that's why these are also called actual positives or true positives, actual negatives or true negatives. So this question is actually very simple. So recall, the definition of recall is Tp divided by Tp plus Fn. So this is Tp is true positive and Fn is false negatives. So true positive means which are actually positive and also predicted positive. So this cell is true positive. 6 is the value of the true positive, and Fn, this one Fn is false negatives. So which are actually positives but predicted negative. So this cell is the false negatives. Actually these are positives, but those are predicted negatives. So 3 is the value for Fn. So you just have to plug these values into this formula. 6 divided by 6 plus 3, which is 6 divided by 9, which is around 0.67. So this is the correct answer. So you just have to find out this Tp and Fn value for the recall. Similarly, if precision was asked, the definition is Tp divided by Tp plus Fp. So in that case, Fp, Tp and Fp, these are the two values that you have to find out from the confusion matrix. In this case, Tp and Fn are the two values that you have to find out for recall. And once you find this out, you just have to compute using this formula for the recall. So this is a Bayesian network given in this diagram with 9 different variables. All variables are binary variables. So which of the following is or are always true for the above Bayesian network? So 4 statements regarding the conditional independency of the variables are given here. A, B, C, D. These 4 options are given. These options. So you have to check each option one by one based on this Bayesian network diagram given in the left hand side, and you have to answer which of these is or are always true for the Bayesian network. So this question might be a little difficult, so it might take some time. So this node is I here. This node is I. It might not be visible because of this thing, but this is I. Simarpreet Kaur says option B, which is probability of AI equals probability of A into probability of I. Anandan says option A, probability of A and B given G is probability of A given G and into probability of B given G. Okay, anyone else? So the correct answer is only option B. Option B is the correct answer here. So you have to check each of these option one by one to check which of these are true. So the first option, option A, says probability of A comma B given G equals probability of A given G into probability of B given G. So this basically means A and what it tries to say is that A and B are conditionally independent given G. So this is the symbol for conditional independency between two variables given G. So A and B are conditionally independent given G, what this statement tries to say. So we have to check using this diagram, Bayesian network diagram. So this is node A, this is node B, and this node is given here, node G. So we can reach from A to B along this undirected path. So you have to find out all the undirected paths from A to B here. So this is one path and there is another path. This one is another path from A to B. So we don't have to analyze this path. If we analyze the first one, it gives you the answer. So this is the undirected path from A to B, and this goes through C. So this is the common child or common effect case of the d-separation rules in case of Bayesian networks. So C is the common child of both A and B. So if C or any of the descendants of C, in this case G, is given, G is a descendant of C, obviously there is a path from direct path from C to G. So if C or any of his descendants, in this case G, is given, then this path is not blocked. So this path from A to B is not blocked by C. If the path is not blocked, then A and B are not conditionally independent. If all the paths from A to B are blocked by one or more variables along the path, then A and B are conditionally independent. But because of C and this G is given, A and B are connected. This path from A to B via C is not blocked, so A and B are not conditionally independent. So this option is correct because of this. This option is not correct because of this. So option A is not correct. Then you have to check for option B, probability of A comma I equals probability of A into probability of I. This simply says whether A and I are conditionally independent or not. No evidence is given, so no variables are given here. A and I are conditionally A and I are independent or not, you have to find out. So this A and I, for these two variables we have to find out. So there are two paths and we have to check if both the paths are blocked, then we can say that A and I are independent. This is one path. So for this path, so this G, this is again the case of common child, because G is a common child of D and F. So G is not given. If G is not given, then G blocks this path here. So this path is blocked because of G. There is another path via B. This is another path. We have to check whether this is also blocked or not. If this is also blocked, then A and I are independent. So in this case, again at C, C is not given. So if C is not given, C blocks this path here. So C blocks this path. So the second path is also blocked from A to I. So both the paths are blocked. First path was blocked because of G and second path was blocked because of C. So both the paths are blocked. If all the paths are blocked from A to I, then A and I are independent of each other. So option B is correct. And similarly you have to check for C and D. So C says whether B and H are conditionally independent given E and G. So here two variables are given. So this is B and this is H, and these two variables are given, E and G. So from B to H there are two paths. This is one path and this is another path, and if you check this one, this path is actually not blocked. This second path, this one is not blocked. This path is actually not blocked. If this path is not blocked, then B and H are not conditionally independent, so this option would be wrong. And then the fourth option says C is independent of B given F. So here is C and here is B, and this F variable is given. So this is much easier. There is a direct path from B to C, so C can never be independent of B. Obviously there is a single direct edge from B to C, so whether F is given or not, that doesn't really matter in this case. C is certainly connected to B via this single edge from B to C, so this is also not correct. C is not conditionally independent, so that's why only the option B is correct, that A and I are independent of each other. So this is how you have to analyze, given two nodes, whether two nodes are conditionally independent of or not, given some evidence or no evidence. You have to use the three rules of the d-separations, and using those three rules you have to find out whether nodes are connected or not. Now question 6. For the given graphical model, what is the optimal variable elimination order when trying to calculate probability of capital E given small e? So this is the Bayesian network. So from this Bayesian network you have to find out the optimal variable elimination order when you are trying to find out calculate the value of the probability of capital E equals small e. Small e can be any value, so we are trying to estimate probability of capital E basically for this variable. What should be the optimal variable elimination order? Anandan says A, Simarpreet Kaur says A. Pandian also says A. So all three options are A here. So the correct answer here is option A. So all the answers in the chart are correct. So from this Bayesian network we can see that A is not dependent on any other variable. So we have to first eliminate A so that we can calculate value of B. Once B is also calculated, now we can calculate the value of C. Then we can calculate value of D. Finally we can calculate value of probability of E. So this is the order. So the order basically follows the topological order of the nodes here. So this is the overall mathematical reason for that. So we have to sum this joint distribution for all the values of A, B, C, D. Because we want to eliminate all these four variables A, B, C, D. We don't want to eliminate E because this is what we want to calculate. So for this, first we will eliminate A and then eliminate B here, then C, then D. So this is the optimal elimination order. Then we will finally get probability of E. consider the following Bayesian network, and the conditional probability values are given below. So these values are given here, probability values for this Bayesian network on the right hand side. You have to find out the probability of D. So P of D you have to find out. So D is this variable using this table here. So this bar represent complement. So like for this probability of C given A bar, so bar is given in the at the bottom of the variable. So this is just probability of C given A bar or complement of A. So this complement symbol is given at the bottom of the variables here. So for this question you have to find out probability of D. This is the variable D. So from this Bayesian network you can see that it is dependent on these two variables A and B. So we don't need any other variables to calculate probability of D. We don't need C or D. We just need these two variables A and B. because D is dependent on A and B. There are direct edges from A to B to D. So probability of D, we can write it as probability of D given AB into probability of AB plus probability of D given A complement B into probability of A complement B. So all these values are given here, plus probability of D given A B complement. So A and B would have 4 different combinations. A B complement plus probability of D given A complement B complement into probability of A complement B complement. And A and B are conditionally independent of each other. It's easy to see that A and D, B are certainly not dependent on each other. These are conditionally independent. So probability of A B would be probability of A into probability of B, and similarly probability of A complement B would be probability of A complement into probability of B. So using this you can find out all these 4 values: probability of AB, probability of A complement B, probability of A B complement, and finally probability of A complement B complement, because A and B are conditionally independent of each other. So probability of A and B are given here, and the conditional probabilities for the variable D given A and B variables are given here. So these are the 4 conditional probability values that you need. So the conditional probabilities appear here. So all the values are already given in this table. You just have to plug these values into this formula for probability of D, and you can find out the value for probability of D. And if you find if the probability of A is 0.3, then probability of A complement would be 0.7. Similarly for probability of B is 0.6, so probability of B complement would be 1 minus 0.6, which is 0.4. So that way you can find out probabilities of A complement, B and B complement. And the correct answer would be option B here. Is there any question or doubt in this problem? SK asks, why is PD not just probability of A into probability of B? So D is a different variable. It is not given that D is equal to A into B like this or something like that. So D is not, the probability of D is not probability of A into probability of B. D depends on A and B values, but it's not that probability of D would be equal to probability of A into probability of B. Now moving on to question 8. The data points shown in the figure below have 2 features, x1 and x2, and each data point belongs to one of the 2 classes shown in this figure by cross and circle. If you have to select one feature to use in a classification problem, which feature will you choose? So there are 4 options, x1, x2, any one of the above. None of the above are suitable. Mishti Pandey says B, SK says C, and Prabha says B. Simaprit Kaur says A and Anandan says B. So in this question, correct answer is option B. Option B is the correct answer. So two features x1 and x2 and the points are plotted. So from this you can see that this is one cluster, this is another cluster. So as these are the two clusters, and simply if you have to use one feature for classification to classify these two classes. You can see that if I draw this straight line, it would simply divide the two classes. So we don't even need x1 values, just by x2 values we can divide the two classes here, because the points are scattered in such a way that x1 values of these data points are not varying that much. X1 values of the this class is same as x1 values of this class, but x2 values are very different. For this first class, x2 values are smaller. For this class, x2 values are higher. So using this linear separator parallel to x1 axis, we can separate these two classes. So this linear separator only uses x2 value. So this, the equation of this separator would be something like x2 equals a or something, where a is a constant. So this is the equation of the straight line. So this basically only uses the x2 feature. It doesn't use the x1 feature, because along x2 we can divide the positive class and negative class, but along x1 we cannot divide. All the points have similar x1 values. So that's why option B is the correct answer. So this question is on KNN, K nearest neighbor. You have been given the following data x and y values. These are the two input variables. X and y are the two input variables, and this is the class, and the class is the dependent variable here. Suppose you want to predict the class of a new data point x equals 1 and y equals 1 using Euclidean distance in 3nn. So in knn, value of k is taken to be 3 in this case. So in which class this data point belongs to? So for this data point x equals 1, y equals 1, so this is the new data point 1, 1, and each of these are different data points. And you have to use 3nn to find out the class of the new data point 1, 1. Simaprit Kaur says option B, which is negative class. Okay. So for this question, you have to basically find out the distance of this point 1, new point 1 comma 1 from each of these points given in this data set, and then you have to find out the three closest points, and the majority class of those three closest points would become the class for that new data point 1 comma 1. So this is the first point, minus 1 comma 1. So the distance from 1 comma 1 to this minus 1 comma 1 is Euclidean distance is root 2. You just have to find out x1 minus the Euclidean distance. You have to find out x1 minus x2 square plus y1 minus y2 square. So if you find out this distance would be root 2 for the first point. For the second point the distance is 1. For the third point the distance is root 2. For the fourth point the distance would be root 2 again, I think. For the fifth point the distance would be 1. Then for the sixth point the distance is 1 again, and then this distance is root 2, and for the last point the distance is 1 square plus root 5. I think this should be root 5, yes. So the three closest points are this one, these three. So all these 3 points are at a distance of 1 unit from the new data point 1 comma 1. So for these 3 points the classes are positive, positive and positive. All the 3 points within in the neighborhood of the new point are positive points. So if all 3 points are positive points, so obviously answer would be positive class. So here the task is very simple, that for the new data point you find out the Euclidean distance from the new data point to each of the points in the data set. Here this is the data set, and then here value of k is 3 here. So find out the 3 closest points of the new data point, and the majority class among the 3 neighboring points will become the class of the new data point. So here the answer would be positive class. Mr. Panda has written positive class, yes. So positive class is the correct answer. Now question 10. Consider the following image showing data points belonging to 3 different clusters indicated by the colors of the points. So I hope the figure is visible here, because these points are red, these points are green, these points are blue. These are the 3 different clusters indicated by the colors. Which among the following clustering algorithms will perform well in accurately clustering the given data? There are 4 options: k-means, single link hierarchical clustering, complete link hierarchical clustering and DB scan. Prabha says option D, which is DB scan. Anyone else? Anandan says option D. So the correct answer here is option D. DB scan, which is a density based clustering algorithm. From this diagram, you can, from this figure, you can see that the clusters are not spherical clusters, for which k-means would have been a good choice. But if the clusters are not spherical in shape, k-means would not be able to find out the correct clusters here. And then the second option is single link hierarchical clustering. So for single link, it would be difficult to find out the exact clustering structure here, because for example, this data point and this data point are very close to each other. It would simply merge the two data points into one cluster, though the points belong to two different clusters. Same thing might happen here. See, these 2 points are belonging to two different clusters, but because of the complete link hierarchical algorithm, it would merge these 2 points into one single cluster, which would be wrong in this case. And finally, the DB scan, which is a density based clustering, and from this figure we can see that the clusters are density based clusters basically. So this is one cluster, this is another cluster, and this one is another cluster. So from the density we can find out the cluster structure here, but using the other algorithms we might not be able to correctly find out the cluster structures. So that's why DB scan is the correct answer here. Yeah, so these were the questions that I wanted to discuss in this live session. Now if you have any other questions or queries, you can ask me. Pandian is saying explain once again question 9. Yeah, so in question 9 you have to basically implement KNN algorithm, where value of k is 3 here, so that's why it is 3NN it is written here. And this is the new data point 11 for which we have to find out the class, and this is the overall data set that is given to us. So from this new data point 11, you have to find out the distance from each of these training data points. These are the training data points. So these are the distance values: root 2, 1, root 2, root 2, 1, 1, root 2, root 5. These are the distance values from this new data point to each of these training data points. And then you have to find out the three closest data points. And these are the three closest data points: this one, and this one. All the other for all the other points, the distance values are much higher than 1. Root 2 and root 5 are higher than 1. So that's why these are the three closest points, and the classes of these 3 points are positive, positive, and positive. So all 3 points are positive, so there is not a single negative point in its neighborhood. So the class is certainly positive for the new data point 1, 1. Simarpreet causes question 3, which was in, yeah, this one B and C are the 2 correct answers, because the first option says that the chance of overfitting will decrease with the increase in the number of hidden nodes and hidden layers. So if you increase the number of hidden nodes and hidden layers, certainly the model would become much more complex. The neural network will become much more complex, so overfitting, the chances of overfitting will actually increase in that case, not decrease. So first option is not correct. And the next 2 options are certainly correct, because neural networks are known as universal function approximators. It can approximate any kind of function even with a single hidden node, a hidden layer. So that's why B and C are correct. Question 5. Question 5, this is very this is actually a difficult question. I already discussed, so, and the video would already be uploaded in the YouTube after this session, so you can check out from there. So basically you have to, if you have not gone through the lecture notes again, so you have to understand the 3 deseparation rules. For that you have to go back and see the video lectures again. There are also many materials available in the YouTube as well. You can just search Bayesian network desuppression rules. So there are 3 desuppression rules, and based on those 3 desuppression rules, you can find out whether 2 nodes are conditionally independent of each other given evidence or not. So it would be better if you go through the lecture notes or see other videos in the YouTube. And I already discussed why the only option B is correct and other options are not correct here. Okay, thank you everyone for joining. If there are no other questions, then we can end this live session here. Thank you everyone.